Okay, the diagram shows the hind leg of a runner. So we can see that this foot is trying to push back on the track. So what stops the foot from sliding further back is the force of friction that is acting forward, which is A. So another way of seeing this question, right, it will be we can imagine the runner stepping on a banana skin. So a banana skin reduces the friction. So in this case, the leg, it will slide backwards. So without the banana skin, what stops the leg from sliding backwards? It will be the force of friction that is acting towards the left. Okay, we can see that there's a rock that is moving at the distance away from a planet. So the rock will be subjected to a gravitational force that is directed to the center of the planet. So because the rock is pulled by the gravitational force, there will be a change in the direction. And since there is a resultant force on the rock, resultant force is equal to ma. It's going to cause an acceleration, so it causes the speed to increase. Okay, in this question, we are being asked the density change when a big triangle is being cut into 3 smaller pieces. Okay, let's revisit the formula of density, which is density is equal to mass over volume. So for the smaller pieces, the mass will decrease and the volume will decrease with it. Hence, there will be no change in the density as long as the material are the same. So answer should be D. Okay, an analogy that we can use to explain this question, right, is that we can see the sweetness of a sweet as density. So when you have a big piece of sweet, you taste it and you will get a certain level of sweetness, and you break the sweet into 3 smaller pieces and you taste it again. They should have the same level of sweetness. Okay, for this question, right, there are altogether 3 forces. There's a weight which is acting downwards, and then the force P is pulling the object horizontally, so force P must be horizontal, and the force of friction F, it must always oppose the direction of the motion. So if we look at the 4 options, there's only one correct option, which is B. Okay, in this question, we have a sliding pan weighing machine. So we can see that the pivot is at X. This is the pivot, and the counterweight is going to act downwards. So it's going to create an anti-clockwise moment about the pivot. And then for the weight in the sliding pan, it's also going to act downwards, and it's going to create a clockwise moment about the pivot. So in order for this weighing machine to balance, we can conclude that the anti-clockwise moment by the counterweight C and the clockwise moment by the sliding pan, they must be equal. So it's either option A or option B. And because the moment is calculated by force times distance is equal to force times distance. Since the distance are different, the force, which is the weight of the counterweight C and the sliding pan, cannot be equal. So the answer should be B.